Okay, this is the day 6 warm-up for unit 5. So express the solution of this equation as a logarithm, then approximate the solution using a calculator, rounding to the nearest hundredth. All right, so we need to know how to solve these. And we could solve these really quickly. Say if I do number 1 and I go into Desmos and I say 5 plus 3 raised to the 2x, and then I press enter. Now, the next side is 13, so you have to put y equals since there's no x's there. And then I can zoom out. So the solution for x, now hundredth would be to 2 decimal places. So it'd be 0.95. All right, so x equals 0.95. However, you also need to be able to write it as a logarithm, like it says in the directions. All right, so here we go. You got to get the exponent by itself first. So subtract 5. All right, so 3 to the 2x equals 8. Once you have this, now if you could get them to be the same bases, you're welcome to. However, in this case, we cannot. So we got to write it as a log. Now, this is written correctly, so I don't have to turn it around. 3 log base 3 of 8 equals, and then the exponent, which is 2x. All right, now what we do is we still don't have x by itself yet. We divide by 2. All right, so log base 3 of 8 divided by 2 equals x. And here's how we can check it. We can actually plug that into one of our calculators. I'll just take this calculator. Recall that to be able to put a log in, we do alpha y equals, scroll over, and it's number 5. All right, this is 3, 8, and then I'm going to take this whole thing and divide by 2. You can write it as a fraction if you want, but you can also do it that way. And isn't the answer, this is the answer that we just got, 0.95? All right, good. So we know we did it correctly. So why don't we do the same thing again for this one? Let's actually solve it on our calculator. Okay, so I'm going to put it in. What am I putting in? Okay, it is 6. All right, times, all right, 4 raised to the, now, I like to just do shift key and the caret symbol. If you're trying to do exponent, you can do a to the b, and then that's what it is. Now, this one, now watch what I do when I do this. X minus 1. Do you see how the minus 1 jumped down there? So here, I actually need to do this in parentheses and then x minus 1. The TI-84 or a handheld doesn't require you to do that. Now we see equals, and I'm going to have to say y equals 18. There we go. All right, zoom out. Here's our answer. Now, 100th spot, 2 decimal places. So x equals 1.79. All right, so we don't have to move it because there's a 2 behind it. All right, now let's write it in terms of log. Now I got to get this 4 to the x minus 1 by itself, so I have to divide by 6. So I get 4 raised to the x minus 1 equals 3. Now, if we can get the same bases, we could do that, but I can't. So I have to write this in log form. All right, the exponent with the, or the base with the exponent's already on the left-hand side, so that's great. I don't have to flip it around. Log base, you start with the base of 4 of 3 equals the exponent of x minus 1. All right, now x isn't by itself yet. I have to add 1 over. So when I do that, now you could do it one of 2 ways. You can do log base 4 of 3 and then plus 1. Do not add it to the 3. Okay, or what we can do is we can add it to on the outside. We can say the positive 1 before log base 4 of 3. You don't technically have to put that plus though. All right, so if we throw this in, I'm going to throw it into Desmos just so we can recall that. All right, so here log is down here underneath functions. Go down to calculus. It's right there, log base 4. Okay, arrow, so the 3's inside the parentheses. Now close the parentheses, and then the plus 1 is outside. All right, and we notice we get that same answer, 1.79 that we just got before. All right, so know how to do it both ways, because even if it's in multiple choice, they may not give you the decimal as the answer. They may give it to you as logs. Now, the other thing is this. Say you find it on the calculator, this solution, you could go through all the answer choices if it was multiple choice, if they were written as logs, and see what they are as decimals and match them up. All right, so that is a way that you can do it. Now, number three, beginning in 2020, Bulgaria has seen a rapid drop in their population. The population has been declining at a rate of 8.1% every 10 years. So pay attention to that. You may want to highlight it, underline it every 10 years. In 2020, there were 6.9 million people living in the country. Write an equation that represents Bulgaria's population, F of D, in millions since 2020 in terms of decades. All right, so we're beginning with 6.99. Now, it also said decline, so that means we're minusing. So 1 minus. Now, if I take 8.1 and I divide it by 100, it moves my decimal place over twice, okay, or just throw it in your calculator. You get 0.081. So that's what we're going to put right here. Forgot my zero. All right, raised to the D. So that's the number of decades right there. So F of D is the way they said to write it. Okay, by what percent is the population declining each year? Well, remember this is a decade. Well, we want to know by each year. Okay, well, what percent is it declining? So let's think about this for a second. If I take this thing right here, okay, and it's 1 out of 10 years, okay? So it's 1/10 of a decade. Now, I'm going to plug this into my calculator. 1 minus 0.081 raised to the 1/10, like that. All right, so here I get, and I'm going to leave like 4 decimal places here. All right, so 0.99, we'll say 16. All right, so I need to change this to a percent. However, remember this is declining. And so this is, think about how far away from 1 this is. So if I say 1 minus 0.9916, all right, so 1 minus 0.9916, I get 0.0084. All right, now I got to change this to a percent. So here to do that, you can move your decimal place over twice or take this value and multiply it by 100. So when I do that, I get 0.84. So it is declining by 0.84% each year. Overall, it's 8.1% every 10 years. All right. Now, when will Bulgaria's population reach 5.5 million? Now, if I'm using this formula, remember this is in decades. All right, so 5.5 equals 6.9, 1 minus 0.081D. All right, now we could plug this into our calculator. So that's what I'm going to do. I'm just going to choose to use Tesnos, a little easier. All right, now instead of D, I'm going to put X in. So 6.9, 1 minus 0.081 raised to the X. All right, and then Y equals 5.5. All right, I already see the intersection is right here, but let me move this over so we can see everything. Okay, so D equals 2.685. Just remember, this is decades. Okay, so here, you need to multiply this by 10. When I multiply this by 10, I get 26.85. Okay, years. From, and what year did it start in? 2020. All right, so when I go and add that, we'll just round this to approximately 27 years. Okay, and when I add that, so it will be in 2047. Oops, and you didn't see anything I was writing right there. All right, so the solution came out to be 2.685, but that's in decades. A decade is 10 years, so I might multiplied it by 10. All right, got 26.85 years. And this is from the start of 2020, okay, from up here. So I added that amount. I said it's approximately 27. So into approximately 2047 is when population is going to be 5.5 million. Okay, and lastly, let's go solve something like this. When it has multiple things with exponents, we can't really write this as a log. Later on in a fourth level math class, you'll learn that. But for right now, we're just going to take this and we're going to take our calculator and we're going to plug it in. All right, so 4 raised to the, now put 2x plus 1 in parentheses. And then the same thing here, 5 raised to the, make sure you put 3x minus 1 in parentheses, or it's not going to look the same. We want to see where these intersect at. All right, well, it looks like, and I'm just going to make this bigger for us. All right, zoom out. All right, now when you start hitting this, you can kind of try to hit, all right, and I'm going to be honest with you, this is hard. That is actually a y-intercept, so that is not what I want. And I'm trying to hit it to see if I can find the gray dot. Now, this may be impossible. There we go. It's right here. Okay, so when x equals 1.457, so 1 point, I'm going to write it down first. So x equals 1.457. I didn't say what to round to, so I'm just going to round it to the thousandths place that I've got right here. All right, so be able to find that. I'm going to be honest, sometimes finding exponentials in here is a little better. And I'll do it for you. It's 4 raised to the 2x plus 1, and then 5 raised to the 3x minus 1. All right, when you go to do this, I just like to say second mode to get out of that. Then when you say zoom, I like to say zoom 6, zoom standard. All right, we can see it start graphing. Now, please realize this goes from negative 10 to 10 and negative 10 to 10. So if you're not seeing it, you would have to zoom out. We don't have to necessarily zoom out here because watch this. The thing in Desmos is you have to be able to see the intersection to find it. Here, as long as the x value is in between the window that's showing, then you don't have to. So if I say second trace 5 for intersect, so I'm just going to press 5 and I'm going to press enter 3 times. Don't even move the cursor. 1, 2, 3. There you go. And it may take a second. We see that we get the same answer. Look at our x value as right here. Now, I didn't have to zoom out. I didn't have to look for the exponent. That's the advantage of these handhelds, especially doing the exponential. If you have any questions about calculators, make sure you ask your teacher. Make sure you know formulas and make sure you understand how to put something into a log and so forth.